My name is Ulrich Hintermair and I work at the University of Bath, and in my group we're interested in transition metal catalysis, and in particular we are interested in finding out how catalysis works in solutions. So we do a lot of in situ spectroscopy, in particular high resolution FlowNMR spectroscopy, which is a very interesting tool for finding out what happens in solution during catalysis. I've always been interested in how things work. I remember as a kid I used to take apart all my toys just to see what's inside and how they work and if they can put them back together. And we take a similar approach to homogeneous catalysis. Because I think sometimes in the area we sort of look down on heterogeneous catalysis and say, oh, these are more stable and easier to apply and also these things, but who knows what happens on the surface. Whereas we in homogeneous catalysis, we know exactly what it is. We've got crystal structures and NMR signatures. But if you really think about it, this only applies to the precursor that you put into the reaction. So what actually happens to that precursor under turnover conditions, so what happens to the ligand, to your solvent, to your additive, and all your different possible products that you might find at the end of the reaction, that is quite an intricate question, and it's not easy to address this experimentally, and this is one of the things that we're trying to do. Try to look into chemistry as it happens. It's quite exciting to work in this area really, because in every project that we've looked at so far, whether it's a literature reaction that's well established and well understood supposedly, or whether it's a more novel system, we have seen new things happening. So side reactions or behavior of your catalyst that you didn't necessarily see by traditional methods if you didn't specifically look for it. So it's quite interesting to see what really happens if you take a close look into the intricate chemistry that catalysis is. And for me, a validation that this is a field that is worth pursuing is that industry is very interested in this. So we've had a lot of interest from chemical companies who see the benefit of these investigations and have approached us to solve or help them solve some of the problems that they might face in practice. Because quite often they take reports from academic papers and then try to implement it on an industrial scale, slightly different substrates, slightly different conditions. And then, you know, the reasoning behind the catalysis doesn't necessarily hold anymore. So they don't necessarily have the resources to follow through and see really what happens in solution. And this is where we can help them out with FlowNMR spectroscopy. Another thing that I think is great in this area is that it makes a very good training ground for PhD students, because it combines many different aspects. So if you want to do FlowNMR spectroscopy on homogeneous catalysis, you need to know your organometallic chemistry, you need to know your spectroscopy that you're using, so it's analytical chemistry, and you need to be quite fit in physical organic chemistry because there's a lot of kinetics and mechanistic investigations involved in there. And it's rare to find all of these in that depth in a traditional PhD project. So I think in terms of training PhD students, this is a very good area to be involved in these days.